All right, so today we're going to look at 3E, volume and capacity. So we need to first define what they mean, because most people have a distorted idea of what volume is. Most of you probably think that volume is how much could fit inside a space, but volume is actually the space that a 3D object occupies. So it's the space that's occupied by a 3D object. And finding the volume is very easy because we're going to be using shapes that we already know how to find the area of. Now, your job, of course, is to find those, make sure you have the pieces in order to find those areas. So let's talk about the steps. The first step is to simply find the area of the base. And that base may not be on the bottom. So we're not talking about base as the bottom. We're talking about the base as a shape that this thing is based on. That could be a triangle. It could be a circle, etc. But you're going to see some shape that you can find the area of from using the formulas that we've used in the past. So it's going to be some shape that you're going to have. All right? Then we're simply going to multiply that area times the length of the object. And the length may not look like a length in some cases. It looks like part of the other formula. You need to make sure that you tease it out to find out what piece it can be. And you may want to rotate these or flip them over. Remember the trapezoid the trapezium that we looked at last time? We had to move it around to make it work. Okay. And with volume, the units are always cubed. So, for example, you'll get meters to the third power. Cubed means to the third power. It obviously doesn't have to be meters. It can be any object, any units. But be careful with these. Make sure you're using the units that they ask you to. So we're simply going to find the area of the base, and that can be any recognizable shape. Multiply that times the length of the object, and make sure that you round properly and that you use the appropriate units. Now, on some of these, when you've done the volume, then you're done. But others are going to want you to move on and find the capacity, and we're going to go ahead and talk about that now. And for all of these that we do, all of the examples, we're going to find both the volume and capacity. Capacity is what most people think of as the volume. What that means is how much, sorry guys, handwriting. How much a 3D object can hold. Now, we generally think of this as a liquid measurement. So when the basic unit for liquids, of course, in the metric system is the liters. It doesn't have to be a liquid, but we still use the liquid measurement when we're doing this. To find capacity, the first thing is that you have to find the volume of the shape. So you see why it's natural that these two do go together, because you always have to find the volume. And then it's simply a matter of converting to liters. So whatever that volume is going to be given to you in measures of length, meters, etc. But you're going to have to convert it to liters. And there's one basic measurement that you could use to convert them all, and then you could convert to the units that you want. And that is that 1 centimeter cubed, 1 cubic centimeter, is equal to 1 milliliter. If you memorize that, because it's not going to be on your formula sheet, if you memorize that, then you can do any of these. But there are a few more that happen so often that you might want to remember them. But this is the basic one. That's the workhorse. It will always work. Okay? We also have a meter cubed. 1 cubic meter is 1,000 liters. Now, these are optional. You don't have to memorize these, but sometimes it just makes your answer faster to get. 1,000 cubic centimeters is equal to 1 liter, but you could have done that with your conversions, converting from liters to milliliters to liters, etc., whatever. All right? And then 1,000 milliliters is equal to 1 liter. That's just your basic conversions that you could do using your factors, your conversion factors. Okay? Now, again, the only one that you have to memorize is that cubic centimeter equals 1 milliliter. And you can get all of the others from that. You can either convert meters to centimeters and then use that number, or you can memorize the other multipliers. All right? So let's just take a look at a couple of these. Couldn't be easier. One of the most common shapes that you're going to see is a cube. Okay? For the volume of a cube, volume is simply equal to the area of one side times another side. So there's not really a formula for it. So, say we have a cube and this length is 5 centimeters. What do you know about the sides of a cube? They're all going to be the same. So so we're going to take 5 centimeters times another 5 centimeters, right? If we're going to say we're looking for the area of this side, then we'll use this as the height. We know that since it's the same, it's just another 5 centimeters. So we just need to multiply those together. So 5 times 5 times 5 is 125. And centimeters times centimeters times centimeters is centimeters cubed. And that gives you the volume for this particular object. Right? If we want to find the capacity, we just need to convert that volume to liters. And since it's given as centimeters squared, 1 cubic centimeter is 1 milliliter. So that means that 125 cubic centimeters would be 125 milliliters. All right? Because centimeters cubed to milliliters is a direct conversion, so the number wouldn't change. From that point, then you could change it to liters, whatever measurement you needed. But in this case, the question just wants to know how many milliliters it is, so we're fine. All right? Yes. Not possible. Doesn't matter. Okay? These are all theoretical, yes. You found a flaw in the thing because obviously you can't have sides that have no length, but no width and no depth, but that's the way it is. All right. This is number 4 in your homework. So in this particular one, we have a rectangular prism. Right? It looks like a box. We have measurements of 50, 20, and 24. And these are in centimeters. So remember that all we need to find is the area of one of those basic shapes. Here we have this end, or we could use this rectangle. Either one of those rectangles could be called your base. Doesn't matter. Which one do you want to use as the base? The 20 by 24 or the 20 by 50? Or the 24 by 50? Makes no difference, right? So let's just use these two. Let's just use this end as our base. So that's 24 centimeters times 20 centimeters. That would give you the area of this base, and which would make this thing then the length. So whatever we get, we'll just multiply it by the 50. Okay. Multiplying those together, 24 times 20 times 50 gives you 24,000 centimeters cubed. Right. Now, if we change that to milliliters to find the capacity, the number won't change, but we'll just have 24,000 milliliters. But in this particular question, they want this in meters. So think about the conversion from milliliters to liters. Is it one jump from milliliters to liters? But we're going from a small unit to a large unit, so we're going to divide by 1,000 using your conversions. So the capacity, if we divide it by 1,000, would give us 24 liters. So be prepared. In this particular one, when we found the capacity, it was in milliliters, but the question wanted us to change those to liters. Okay? So let's just go to the book and look at one. Now, on this one, you're going to have to be careful because when you're dealing with some of these shapes, you're going to have to find the area of the base, and you're going to have to pay close attention to how that works.